Hello everybody and welcome to another video by the Science Sound. Today we're going to dive in deeper into more advanced trinomial theory, and more specifically we're going to talk about parametric equations of second degree. In this video we're going to provide you with methods to face parametric equations. We're going to give examples, and most importantly, if you stick till the end of this video, you'll get a free PDF with exercises covering this topic, with our difficulty ranging from simple exercises to extremely difficult and challenging problems which are almost impossible to solve. So, without further ado, let's get started. In one of our previous videos, we talked about how to solve equations of the general form ax squared plus bx plus c equals 0, where a, b, and c are known numbers. For example, the equation x squared plus 5x plus 3 equals 0, with coefficients a equals 1, b equals 5, and c equals 3, can be easily solved using the formulas we've learned. But what happens when a, b, and c are not known? In that case, we say that we have a parametric equation of second degree. Let's take a look at some examples. Example 1. For all the different values of m, solve the equation x squared plus mx plus 1 equals 0. Now, what is the method to approach such equations where one or more of the coefficients are unknown? It's simple. We determine the discriminant. Applying the formula, we get t equals to m squared minus 4. Since we don't know the value of the discriminant, we must distinguish cases. And the way we do this is by following this simple theory. If it is negative, we get no solution. If it is equal to 0, we get one solution, x equals to negative b over 2a. And finally, if it is positive, we get two solutions, x equals to negative b plus minus the square root of t over 2a. Case 1. T is less than 0. In that case, we must have m squared minus 4 to be less than 0, or m squared to be less than 4, which gives us absolute value of m to be less than 2, and therefore m is in between negative 2 and 2. Thus, the equation has no solution when m belongs to the open interval from negative 2 to 2. Case 2. D equals to 0. In that case, we must have m squared minus 4 equal to 0, which gives us m squared equal to 4, and thus absolute value of m equal to 2. Therefore, m equals to 2, or m is equal to negative 2. Applying the formula x equals to negative b over 2a, we get, if m equals to 2, then x equals to negative m over 2 equal to negative 2 over 2 equal to negative 1. And finally, if m is equal to negative 2, then x is equal to negative m over 2 equal to negative of negative 2 over 2 equal to 1. Case 3. This is positive. In that case, we must have m squared minus 4 greater than 0, or m squared greater than 4, or absolute value of m greater than 2, which gives us m is greater than 2, or m is less than negative 2. Either case, we get two solutions, x equals to negative b plus minus the square root of t over 2a. In our case, we get x equals to negative m plus minus the square root of m squared minus 4 over 2. Now, to sum it all up, we have, if m belongs to the open interval from negative 2 to 2, then we have no solution. If m is equal to negative 2, then we get one solution, x equals 1. And if m equals to 2, then we get again one solution, x equals to negative 1. Finally, if m belongs to the open interval from negative infinity to negative 2, union the open interval from 2 to infinity, we get two solutions, x equals to negative m plus minus the square root of m squared minus 4 over 2. Example 2. Find k such that the equation x squared plus k plus 1x plus k plus 4 equals 0 was one double solution. For the value of k you have found, solve the equation. Let's look at all of our data. We want our given equation to have one double solution. That means that the discriminant must be 0. Thus we have k plus 1 squared minus 4 times k plus 4 equal to 0, which gives us k squared plus 2k plus 1 minus 4k minus 16 equal to 0, or k squared minus 2k minus 15 equal to 0. Now we're going to solve this equation. The discriminant of this equation is d prime equal to negative 2 squared minus 4 times negative 15 equal to 4 plus 60 equal to 64, which is positive. Therefore, we get two solutions. We will apply this formula and we will get k equals to negative of negative 2 plus minus the square root of 64 over 2, equal to 2 plus minus 8 over 2. Thus we get k equals to 5 or k equals to negative 3. If k equals to 5, then the equation becomes x squared plus 6x plus 9 equals 0, which easily gives us x equals to negative 3. And if k equals to negative 3, then the equation becomes x squared minus 2x plus 1 equals 0, which gives us x equals to 1. You can verify the solutions yourself if you want. Example 3. Find a such that the equation a minus 3x squared plus 2 times a minus 1x plus a plus 3 equals 0 has two different solutions, which you should determine as a function of a. Now remember, to apply the formulas of the discriminant, we must have that the coefficient of x squared is not equal to 0. Therefore, we must take two distinct cases. If a equals to 3, then we get the equation for x plus 6 equals 0, which has exactly one solution, x equals to negative 3 over 2, which is not what we want. Now, if a is not equal to 3, then we get a second degree equation indeed, whose discriminant is d equals to 2 times a minus 1 squared minus 4 times a minus 3 times a plus 3 equal to 4a squared minus 8a plus 4 minus 4a squared plus 36 equal to 40 minus 8a. In order to have two solutions, we must have the discriminant must be positive. Therefore, we must have 40 minus 8a to be greater than 0, or 40 to be greater than 8a, which gives us a to be less than 5. Now remember, a is not equal to 3. Therefore, we get two solutions when a belongs to the open interval from negative infinity to 5, excluding the singleton set containing number 3. The solutions are x equals to negative 2 times a minus 1 plus minus the square root of 40 minus 8a over 2 times a minus 3. And that's the end of this video. In the description, there's a free PDF with exercises over the topic of parametric equations of second degree, categorized in 3 different levels based on difficulty. Along with the problems, the PDF contains hints which you can use when you don't know how to solve an exercise and want a bit of help. And finally, at the end of the PDF, there are full solutions to all of those problems. So, if you want to practice your math skills or challenge yourself with some very difficult problems, you can download this PDF directly from here, simply by clicking the download link in the description. If you enjoy our content, don't forget to like this video and subscribe to the channel. Thank you for watching.